Hello everyone. Uh, Today we are going to learn about how to design a base plate for transfer column. So transfer column is the one which is sitting on the beam and not on the directly resting on the pile cap or pedestal. So there will be a beam above which there will be a base plate on which the column is going to sit. So today we are going to design the same connection. As you can see here, we are using idea statica, and it provides us a variety of settings by which we can choose, like for example bolt assembly, we can choose a steel grade. There are various design codes, we can choose concrete grade as well. Let's say I want a 4500, so let's select it, create project. We can choose from the connections which idea static also provides, and but today I'm going to make it from scratch. Let's say we add a member 1. So geometry we are going to select is W30 by 292. Let's type in. So I'm going to select ASC code. Okay, here member 1 is been added. Let's make it continuous, or you can also select end if it is your condition. Currently I'm keeping model type as all the forces, and there are forces which are going to be transferred to node. Second is I'm going to select a column size here, which is going to be a W14. Let's say uh, W14 by 61. So as you can see, M2 member has been added. Here there are various settings by which you can choose the alignment, proper alignment of the member. Since we have here a column, so it's going to be vertical, but let's say you can also switch the direction of the rotate. You can also rotate it. There are these offsets. So coming back to a column, let's say 90 degree. Now we have chosen the member W30 by 292. So if I have to see its place the column properly, it should be uh, let's first see the depth of the W30 by 292. You can go on any website anyway. So the depth is 32 inches. Coming back to idea statica, we'll put an offset of half depth, let's say 16 inch. Okay, so and second, yeah, it's in the M2. So M2. Then coming back to geometrical type, it should be ended, right? As since it is resting on beam. So 16. Now model type should be, you can select any one according to your condition. I'm only having a axial load, so NVZMY should be fine for me. Forces in bolts. Taking the operation into consideration, I have this end plate connection, so I'm going to choose one. We can choose any bolt assembly. It also provides us with the different pre-designed bolts, 12, 16, 22 bolts. You can also change it later on. So let's say 325 volts. As you can see, it has added the operation. Now the member is getting connected with M2, and it is then connected to M1. So thickness, let's say I'm going to put it as 1 inch. You can do by trial and error and see which one perfect let's say 0.5 inch I want it next to the top flange, and zero point 0.5 from bottom, and to the left and right I'm going to be 0, put it 0. So A325 bolt grade is selected. You can change the bolts geometry of bolt, or as to say bolt placing from here. So let's say ordinate it should be minus 4.95 and 4, I guess. I want to keep this bolt spacing. Then from right and from left it can be minus 3. Still one extra bolt. There's an extra bolt line over here. 1954. Okay. Yeah, I should remove this minus 4. And we can put it that way as well. Let's say, and I can put in the bottom layer. The calculation went wrong, so let's put it over here, bottom layer. Let's put one bottom layer, minus 4 should be setting it. No, okay, it should be minus 4.95. So 4-inch spacing and 4-inch vertical and horizontal as well. So yeah, let's change the wheels. Let's say 3/16. Let for the time being. Putting a load effect, then my load is going to be acting at the end of the member M2. So let's say for 750 kPa force is getting added, then that's it. We can do the calculation now. You can see all the geometry and load effects and bid has been added. Okay, so I guess it's failing in welds, right? So let's do one more trial. 1/4 inch, 1/4 inch, or we can say 5/16 inch. Oh, okay, still the DCR is good, more than 100%. You can always go to check and you can see where it is exactly failing. But since it's not showing me, I'm using trial version obviously. Let's go to report, by the way. You can do it that way as well. Let's click generate, then it does take a little bit of a time. Okay, as you can see, wheels are not okay. You can also see other properties like strain and all. Currently, since it is failing in wheels, let's see. Uh, Keeping it 1/2 inch, right? I'll try it with that. Okay, see, now the wheels are passing. So as you can see, everything has been passed, and we can go to report. You can always see detailed report calculation and report over here by going into report. Okay, you can see details over here, like balance trace, train check, bolts, design data, and the trace and all. And let's say I want if I want to check the stiffener, if I want to add a stiffener, so idea statica does provide us with this setting. Let's say half-inch stiffener should be fine. It's more than fine actually. Where it should be more than 5 by 16 or 5 by 8 times the plate thickness. As per AIC manual, I don't remember it exactly. You guys need to see it. So let's say since we uh, do not require stiffener, it's not actually calculating stiffener. You can do the buckling check and all. By clicking on the theoretical background, we can get the theoretical background behind this. So as you can see, our connection has been checked. Thank you all.